Greetings. In this video, I'd like to show you a method to solve a kind of interesting but simple kind of argument inside an integral. So let's say I have this kind of integral where the argument is 1 over x to the first power or and plus or minus. So basically an addition or subtraction of two terms where one is x to the first power, so x in the first degree, and the second one is in some higher degree, let's say 10th one, for example. Dx. Alright, so what I'm going to do is basically solve such an integral, where this is an integral where you have 1 over x to the first power plus or minus. It works in both cases, just will end up being solved a little with a different result, but the method is the same almost. And what I have here is x to the first power plus or minus x to some higher power. And the basic idea is many might consider factoring out x to the first power, so finding this common factor being x to the first power. But actually, it's better to use x to the 10th power, so the higher degree term, as the common factor. And I will do it as follows, and I will show how that works out and why it actually enables USUP to be used for the solution of such an integral. So what I have here, I can just factor out this x to the 10th. So what I get is x to the minus 9 plus 1 in the denominator. Here, besides this x to the 10th that multiplies the parentheses, dx. But now, to just start the USUP and show why the USUP actually works, I'll just work it out. So the point is, I will set this to be USUP, this to be U, and it actually does work very nicely. So U will be x to the minus 9 plus 1, and of course, to get the du, in terms of du, I want to replace this dx. So what I will do is differentiate u with respect to x, so du over dx. It does this, minus 9x to the minus 10. And this term of this constant term, of course, gets cancelled by the differentiation. Now what I want to do is express for dx in order to replace this dx in terms of du and whatever else comes into play here. So dx is, by algebraic manipulation, equal to du over minus 9x to the minus 10. Now, this is what I can replace the dx by. So in the next step, I will just replace the dx as well as say that this is u simply. So x to the 10th times u in the first fraction of the argument of the integral. So 1 over x to the 10th times u, and then this gets multiplied by du over, because this replaces dx, du over minus 9 x to the minus 10. And this is all argument of the integral, and as visible, that's why the USUP works in this case, and it works out very nicely. This x to the 10th power cancels out with this x to the minus 10th power, as well as this minus 9 in the denominator. What it means is I get this constant multiple outside of the integral. What one can do is minus 1 over 9, get it out of the integral, and the only thing that's left inside the argument is 1 over u du. And what this basically ends up being is minus 1 over 9 ln u plus c. But of course, just to return what u was meant to be, u was this thing. So I will plug it instead of u. I know this is ln of x to the minus 9 plus 1 equal plus c. And this is the solution to this integral using USUP.